Okay, we have a sprinter starting from the starting blocks and reaching a final speed of 11.5 meters per second, and it takes them 15 meters to get there. So let's see what information we given. I know this here is going to be my V final. And again, just kind of keying in on when you're looking at these questions, how to find your V initial. Well, I'm starting from the starting block. So this says my V initial is 0. What else do I know? I know that it takes me 15 meters to get there. So let's go ahead and make a list of what we have. I have my V initial is 0. My V final is 11.5 meters per second. And I know my delta x is 15 meters. So this wants us to solve for acceleration and for time. So let's see what we have. I look at my first equation. This one requires time. This one requires acceleration and time. I'm sorry, they both require acceleration and time. This one has no time component in it. So I can solve for acceleration using this because I know my V final and my V initial. And this looks kind of daunting. People try to stay away from it because of the squares. And they don't want to do any kind of quadratic equations. But when we look at this, we know what these values are. So let's start there. So I can look at that and say, okay, so I have V final squared equals V initial squared plus 2a delta x. I have delta x, V final, and V initial. And my V initial is 0, so that simplifies that. Don't do that. Sweet. So I can rewrite this. I can go V final squared equals 2a delta x. Well, what piece do I want? I want acceleration. I want acceleration. So I can divide this side by my 2 and my delta x, move it over to this side, and I'll get V final squared divided by 2 delta x will give me acceleration. Okay, that's not so bad. I can also look at this and say, okay, so now I have acceleration. For the piece that wants time, I can do this mess. I now have all the pieces, but I look at this, and this is just the definition of acceleration. So if I'm doing it at constant acceleration, all of these things apply. If my acceleration is changing, I cannot use the equations of motion that I have here. But it's not. It's constant, so I can use that. So then the second equation I'm going to use is, let's see, V final equals, actually, let's write it down here. Last one I'm going to use is V final equals V initial plus AT. And then remove the pieces that are ugly. 0. So if I want, I can look at this in terms of, I've defined acceleration. I can go V final then equals V final squared over 2a delta x, over 2 delta x, excuse me. Times t. And what do I want? I want time, so I can rearrange this. So what's going to happen is I'm going to multiply this thing, so you can see the math that I'm going to do here. I'm going to go 2a delta x divided by V final squared on both sides of the equation, and that's going to give me V final, let's see, divided by, I'm sorry, V final, my brain did not work for a second there. 2a delta x, or 2 delta x divided by V final squared, and that's going to equal the amount of time. And I look at this, and once again, things cancel. So this final equation is going to look something like 2 delta x divided by my final velocity gives me the amount of time. Sweet. So I can do this either way. I can start here and solve for acceleration. I can start here and solve for time. Start here, solve for time, go back. I'm sorry, I keep forgetting you can't see what I'm pointing at. Start here and solve for time, and then go back and apply that to the first one. It's up to me. I can solve for both of them and never back substitute anything. It makes no difference. So let's see. Let's just go ahead and go 2 times 15 meters divided by my V final, which is 11.5 meters per second. Now let's look at our units real quick just to confirm that we've done everything right. And I look, my meters cancel out. My seconds is on the bottom of the fraction here. That's going to pop it up top, and that is going to give me something defined in terms of time. So I'm going to have good units there. So this is going to give me like 30 divided by 11.5 equals my time. And then on this one, what am I going to have? I have my 11.5 squared divided by 2, and my change in position is 15 meters. Let's do my units there. 1.5 meters per second squared. And I can do a quick check on the units. This one here is going to be meters squared per second squared divided by meters. Or another way to look at that is meters squared divided by seconds times meters. Seconds squared times meters. So indeed that cancels out and does give me the correct units of acceleration. So we don't have any errors there. So that's nice. So let's see what the answer is. So 11.5 squared divided by 30. So this one gives me acceleration of 4.4 meters per second squared. And this gives me time equals 30 divided by 11.5, 2.6 seconds. There you have it. So it is absolutely up to you which way you want to do it. If you wanted to solve for acceleration and then put it into this top equation, you can do that. What I do absolutely require is that you can't just look up on the internet how to solve for one of them and start with that. You will either need to use the calculus or start from here. And I will provide you exactly what equations that you can use, and those will be the only ones that you can use without deriving. So keep that in mind when you're solving these. It's good practice.